All right, hey everybody. So we're here to talk about the Smithsonian 3D open source pipeline. So I'm Vince Rossi, I lead the 3D program. I'm also here with my colleagues Jonathan Blundell. John's a 3D program officer, and Ralph Wiedemeyer, who is a software architect working for Frame Factory and working for our team. So I'm going to talk a little bit about the history of our program, overview of the Smithsonian, and then we'll dive into some of the details of the pipeline. So the Smithsonian, we're not one museum, we're 19 museums, 9 research centers. We have scientists operating in over 100 countries around the world, and we have this huge collection. We have 155 million objects, and less than 1% of that collection can ever be on physical display. So this is really what inspires our team. You know, what if we were to unlock more of this collection using 3D scanning tools? So some of our kit on screen, tools of the trade, depending on whether we're scanning an insect or an aircraft, that's 2 very different sets of tools and workflows. For this presentation and for what we're looking at scaling up first at the Smithsonian is photogrammetry. And the reason for that is that we have a good idea about how we can preserve photographs compared to some of the more proprietary file formats that come out of these other scanners on screen. So this is our team, a Brady Bunch reference. So yeah, we're a fun team. We have a lot of fun. And we operate sort of like a little startup within the Smithsonian universe. And some background on some of the work that we've done. From 2006 to 2012, we really focused on like broad use cases, working with exhibit developers for different 3D applications around 3D printing, 3D scanning research sites for researchers around the world. But nothing really online until 2013. And this is either pre-Sketchfab or just as Sketchfab was spinning up. So we partnered with Autodesk, and actually we started working with Ralph when he was working at Autodesk, and now he's working directly with us. And this was really our first exploration onto delivering content using WebGL to anyone in the world with an internet connection. And the goal was really, how do we deliver this content to the world, but also kind of pair it with the content experts that we have. So how do we use a 3D model as a scaffolding for storytelling? But this solution was a great experiment, but it didn't scale. Then the second generation of this viewer was Autodesk's Play. And we had some new tools, new functionality. But the problem was this was a third-party commercial solution, and eventually we stopped seeing the support that we really needed. So we have this great partnership with Autodesk. It still exists to this day, but this tool is reaching its end of life. So we've learned a lot of things, between 2006 and 2016. So from 2017 to present, we've been working on the Smithsonian open source 3D pipeline. That includes a 3D viewer, but it really takes a holistic view in how we capture, preserve, author, and deliver content. So we're definitely looking for partner institutions to contribute development. So if there are other institutions interested in doing 3D or they're doing 3D and they have developers and they want to help, we would love to talk to you. All right, so this is a fun project, scanning the T-Rex and Triceratops. Ralph's going to be demoing this with our new viewer. But this is going to be coming soon, so you'll see this coming online the next month or so. So keep an eye on your Twitter feed if you're interested in downloading this full resolution data set or just checking it out online. And this is being launched in collaboration with the Natural History Museum, where they're opening up the Deep Time Hall. It's been closed for 5 years. So that T-Rex project, that was a fun project, but it took a lot of time, a lot of resources. It's a big, complicated object. So we're kind of pulling back on those one-off projects and really thinking about how do we 3D scan entire collections. And we've done that with these coral collections. These are type specimens, the specimens that define the species, running photogrammetry systems, and really using that to drive development for this pipeline. So finding the pain points in the processes, resolving those pain points, and again, driving the development of the pipeline. So this is the behind-the-scenes stuff, some of the 155 million objects we have in the collection. And, most humans on Earth, some researchers get to see it. I work at the Smithsonian. I'm super lucky. I get to see some of this stuff. But most people never see this. So This is really what inspires our team. We're not proposing we're going to scan 155 million objects, but we do want to increase the throughput so we can unlock more of this collection for the world. So here's the other dream. We walk up to a scanner, we push a button, and it scans it, it processes it, delivers it online. So for those of you who do 3D scanning, no, that's far from reality. But that's actually what we're starting to do is with the pipeline, we're automating certain steps that we know that are automatable. And Ralph will talk about that shortly. Okay, so overview of the pipeline. We don't have time to get into capture technologies, but let's assume a capture event like the T-Rex. The T-Rex gets ingested into our asset management system, PackRat. John's going to be talking about PackRat and our asset management system. And then, of course, tomorrow during the workshops, for those of you who are coming, we're going to go into much more detail. Cook is a processing service, so we will automatically process the data. So we feed it a master model, the highest resolution model we have, and we automatically create a bunch of derivatives. And Ralph will go into detail about that. And then we send that data and derivatives to Voyager. And that's where we author content. So we're authoring content in a way that's really standardized so that if we had an annotation on the horn of the T-Rex, that annotation and that world coordinate space is written back all the way through the repository. And that's important because when we push this content through our API, we deliver it to Voyager, the public viewer, excuse me. But then we also get extensibility to all these other platforms. So that's in the future. We're not at the point where we're going to be delivering to all the different web viewers out there, Sketchfab, Google Poly, VR and AR platforms. But we're building for a future where we have that potential. And we'll have an open API so we can partner with some of these folks and make that happen. So at this point, I'm going to pass it off to John, and he's going to give you some details on our asset management tool.
Great, thanks, Vince. All right, so I'll be talking about PackRat, our 3D asset management platform. So we're developing this tool to do a few things. We're looking to preserve the assets we're creating, that's capture data in models. We're looking to store metadata about those assets. We're also looking to create and store annotation information, tour information about those 3D models. And then we're trying to we're facilitating access through the API. We're not trying to create another data silo, so PackRat is kind of our interface to get data to the API and manage that. So what assets are we storing? We're storing two main types of assets. One is what we're calling a master model. That's your highest resolution, best quality 3D data that represents an item you scanned. That's what's citable, that's what you assign the DOI to, that's what you create derivatives from, but that is the research model. The other, and importantly, is the data sets. In our case right now, it's photogrammetry, as Vince mentioned, that's what we're focusing on for the tool. So all the image sets that go into creating a 3D model, we also ingest those and keep those connected to the model. And then importantly, we're capturing all the metadata, the paradata, the creation metadata, about those, excuse me, about those assets. So for the data sets, for the image sets, we're collecting any capture event information. And then for the models, we're tracking what data sets go into their creation, as well as what processing actions created those models. This is super important. Anytime you're looking at a reality capture 3D model, there's a lot of interpretation you're not necessarily seeing. The scanner, the light hits the sensor, it gets interpreted, put into some sort of file format that you ingest into a processing software. Algorithms or a technician using that processing software make further interpretations to create the 3D model. So we want to be transparent in what we're presenting and make sure that the users who are interacting with our content can separate signal from noise and know what they're looking at. All right, so PackRat manages our entire workflow. I'm just going to talk about the ingest section. So for ingest, our submission information package consists of two parts, our assets and our metadata. Our assets are bagged up with the Library of Congress Baggett specification. Essentially, that lets us assign a manifest and checksums to our files, so when they get to where they're going, we can validate that all the files got there, and bit for bit, they're the same files. And then next, I want to talk about the metadata we're associating with the files. So there are 4 main categories of records that we're attaching to these files. The first two are what we're calling subjects and items right now. A subject is essentially It points to the collection record, the authoritative source record for that thing that was scanned, and the item describes the thing that was scanned. So in this example, the subject is MR 555, that's the nation's T-Rex at the Natural History Museum. It's got a record in their collection information system that's for the entire T-Rex. We scanned the entire T-Rex. We also scanned each individual bone. So the item describes what was scanned. Do we scan the entire articulated skeleton? Do we scan the nose, the arm, the leg? We want to know what actually is in that capture data in that model. Next is data sets. This is a super dense area. I'm just going to go like a just a couple of high-level elements that we're capturing. For example, we want to know, did the sensor move around the object? Or did the object move relative to the sensor? This is super important if you're processing that information. Similarly, the object, to capture it fully, we might have to move it. So we want to know from data set to data set, has the object moved? Do we need to shift it for some reason? Similarly, if the object's deformable, did it deform between different captured data sets? We want to know that for processing. Again, there's a bunch of other information we're capturing here depending on the capture techniques. I'm not going to go into them. Next is model. Basically, for model, we're capturing anything that's not inside the embedded inside the 3D model file itself. So, of course, no 3D models, they don't include scale for whatever reason. So we include scale. Is it in inches? Or the unit centimeters? And then any maps we're including. What are those maps for? Normally, it's going to be diffuse, but maybe we're including like an OA map or a normal map. Anyways, so that's the full submission information package. So pack that all up, ship to the repository. It ingests it. We do a little bit of validation. We do that Baggett validation. We also do metadata validation, make sure it matches our metadata schema. And then we also do file validation, make sure those images are valid TIFFs, valid JPEGs, the 3D files are valid 3D files. I can open them and use them. They weren't corrupted before I zipped them up into that Baggett package. Yeah, so hopefully it goes okay. We get the information into our repository, and then we kick it off to the next step, which is a cook. And I'll let Ralph talk about that.
All right, thanks, John. So I'm Swiss. I'm going to talk a little bit slower. Hope that's okay. So I'm talking about the next two stages in our pipeline. One is the cook, which is our processing service. So whenever the Packard Asset Management needs to process some data, reaches out to the cook, and the cook takes care of that. So here's our initial dream. So we really want to somewhere in the future be able to really just take a model and then somehow push a magic button and have it delivered to whatever channel we want to have it on the web or in an application or wherever else. So this is what we basically have in mind. If we do photogrammetry, after the photogrammetry process completes, what we end up with is what we call a master model. The master model is basically the ground truth in the 3D realm. But the master model, unfortunately, is usually very large, so it can be several gigabytes in size. So very difficult to distribute that to channels with narrow bandwidth or with just not enough processing power, like the web, for example. So among the platforms we target are like mobile and desktop browsers, platforms like AR and VR, 3D printable. We want to provide downloads for 3D print, but also for editorial or for research purposes. So each of those platforms has different needs. And so what we did so far in the past is, and all of you that handle 3D data know this picture and the kind of nightmare it is. There is no single tool that can do all of this. So we really need to basically involve a whole bunch of tools. They run on different platforms. They support different file formats. Sometimes they fail, so you need to reach out to another tool. But then you figure out that tool A can only talk to tool B, but not to tool C, and so on. So we really wanted to find a solution to make this more reproducible, and also so that we are able to automate this and scale this in the future. So this is our cook, how it works. Like in a regular kitchen, we have ingredients. These are our 3D assets, mostly the master model in this case. And then we can provide recipes. Recipes are basically describe what we want to do, but they don't describe how we do it. You just say, hey, please decimate this model, then bake the textures onto the low-res model, create a UV map or whatever. The cook takes over, has all the expert knowledge, on how to do this, which tools to involve, and finally, if everything goes well, serves you the final assets. So on a technical level, it looks like this. The cook runs on a web server, has a web user interface, so we can directly interact with it, or you can remote it through a web API. And then the cook basically offers you these recipes that it knows about, and then processes your data according to the recipes by reaching out to all the individual tools behind the scenes. This is not something you need to take care of or be familiar with. The cook knows exactly how to remote control each of those tools. If something fails, the recipes usually have a second path or an alternate path, so they know how to reprocess things using a different tool chain, for example. So another thing the cook does is it keeps track of everything that happens. So each of those tools, they provide certain output, they log errors and whatnot. We also record like the versions that we're using, so that at a later point in time, we can basically replay the entire process. We can also provide this information downstream to users so that they know exactly what happened along the process. If you use our models for research purposes, for example, you want to know exactly what happened to the data along the way. So more about the cook, by the way, tomorrow in our workshop. We will show you a live demo also and process some assets there. So the next module I want to show you is Voyager, which is our new viewing platform. And you might ask, why, again, another 3D viewer? We already have so many. So one of the reasons is that we really want to focus on stories. So the viewers we had so far were basically model-centric. So you could look at one model at a time, you could examine it, you could spin it, but there was like very restricted possibilities to do comparisons, for example, or to show things on a timeline or in any kind of context. But what you do in the real museum is basically, you do not show stuff that's in a drawer to people. You take it out of the drawer, you put it on a stage, you add context, props, and lights, and then basically create a story to experience. And we want to do the same in the digital realm. So we take our digital models, we put them on a stage, we add context, props, lights, and then provide a story to experience. We created a little ecosystem of different tools, because if you want to provide these stories, the viewer itself is not enough. You also need a place where you can actually author and create this content. So at the bottom, you see Voyager Explorer, which is our public-facing viewing tool that runs in a web browser. Everything has a common core module, but in the backend, we also have Voyager Story that we use to do two different things. So we provide this to 3D technicians to do quality management, quality inspection, and kind of technical checks on the models. And then we also give this tool, Voyager Story, to curators and authors, so they can do things like adding annotations, articles, create entire guided tours. That's all I have on my slides. But I think far more interesting is to see this in action. So, it's a world's first preview of the T-Rex that we just scanned in our new Voyager platform. So this is a full 3D model, so you can spin it around, do the usual stuff like zooming in and out and exploring different aspects. We have a lot of context information that goes with the models. So for example, we have an article reader that you can overlay that gives you some introductory information about the model. You can add annotations. So here we have a bunch of bones that we labeled. You can connect a lot of things. So you can, for example, have annotations clickable. So if you click them, they reveal more information or link to an article or do all sorts of fancy things. Then we have a toolbox. It's quite interesting. I hope you can all see this because it's at the very bottom of the screen. It's at the bottom because we are actually designing mobile first. So if you're on a mobile device, you want to use your thumb to navigate this. Here you can do things like change the view. So just change to an orthographic view, or have some default views that you can call on. You can change materials. If you want to remove the texture and see this in clay, for example, or you can do X-ray, which is pretty cool. Check out the normals. So we really want to provide people with tools that that are not available in the museum, right? So in the museum, usually everything is behind glass, you can touch it. We really want people to interact with the models. We also have a measurement tool. So if you want to check out the size of the jaw, just measure it. You see it's 1.3 meters, quite impressive. We also have a slicing tool, so it can cut through things. And the tool system is pretty pluggable. So if in the future, you want to write your own tools or add some more stuff, this is pretty easy to do. Then we have a tour system. So for those people that are lazy, don't want to click around themselves, they can just go on a guided tour. And on a tour, this turns into some sort of live PowerPoint where you have different steps. And you can automate every single parameter that's in the browser, in the viewer available. So for example, you can automatically have articles pop up or other text elements, other descriptive things. You can automatically bring up the labels, change the camera, and change material parameters. There we go, zoom in on something, give more explanations. We also plan to add audio and video to this. So you can automatically bring up some narration or video clips, and so on. We're going to show more about this in the workshop. Just a very quick glimpse. Sorry, this was wrong. What I want to show you is I just switched to a different page, and what you see now is basically our authoring system, where you see the structure of the scene with all the parameters. So you have a bunch of tools. You can do tours, edit them in our tour editor, for example, and so on. So it's a full animation system built in. Again, so we're going to present this in detail tomorrow at the workshop. The whole viewer is built as a web component. So if you're a little bit familiar with web design, custom web components are basically the future of the web. They're very easy to integrate in any existing web page. So just as a little example at the end, this is a page with like 9 components, and with just 2 lines of code, you can, for example, synchronize the navigation and do pretty cool stuff like presenting collections in very new and interesting ways. All right. That's all I have. All the tools are available, are open source, so they're on GitHub. We are not finished with everything yet, so it's under development. It's at your own risk. Documentation is coming, it's in the works, and breaking changes might still happen, so be careful, but we're looking forward to get your feedback and contributions. If you want to contribute, we're really happy to see more contributions to these open source projects. Thank you very much. QR code for the slides up there.
Amazing, thank you. Well, Lynn, it's up to you.
Thank you. I'm going to be talking today about 3D imagery for interactive apps, and in particular focusing on the ALAP, or Advanced Limes application. And this presentation really will look at how we use and apply 3D data from scanning and photogrammetry. I'm the Digital Documentation Manager at Historic Environment Scotland, which is the lead public body for Scotland's historic environment. And we use the term digital documentation to refer to the data capture, usually in 3D, from any type of information source, so from laser scanning and photogrammetry in particular, but we use whatever is appropriate for whatever project we're looking at. So the Antonine Wall in Scotland is the main focus of the presentation today, and I'm guessing that many of you will not have heard of it. It's part of the Frontiers of the Roman Empire World Heritage Site. It's the most northerly frontier of the Roman Empire in Scotland, and it was inscribed by UNESCO onto the World Heritage List in 2008. There's some other stats about it there. I'm not going to read them all through. But key to this is that the archaeology is only visible at a handful of locations, and the image that you can see in the slide here is actually one of the most visible locations, so there's not a huge amount left. So digital interpretation is really important for how we tell the stories and how we help interpret the Antonine Wall. It's managed by Historic Environment Scotland and 5 local authorities, so quite a challenge in terms of how we manage such a disparate site. There are a lot of Roman artifacts that have been found at the Antonine Wall sites, and these are housed in several different museums across Scotland as well, which also presents an interesting challenge for us in terms of how we bring all of these stories together. We began our journey in digital documentation of the Antonine Wall as part of the Scottish 10 project, which I managed with my colleague Alistair Rawlinson, which saw us digitally recording all of the, as we had then, 5 World Heritage Sites in Scotland. And for every site we recorded in Scotland, we also managed to create 3D models of an international heritage site, and you can see those along the bottom there. And the goal there was to create the 3D models to help in the conservation and management of these places. And following on from this, it's my team's responsibility now to deliver a project called the RAY project, which, similar to Mona Hess's presentation yesterday, where she talked about a project which is going to span 25 years, I think ours might take that long, or possibly even longer. We have 336 monuments to record across Scotland at very high level of detail, everything from Edinburgh Castle that you can see here to Antonine Wall sites. And we also have collections associated with these sites. Not nearly as many as Vince and the team have at the Smithsonian, but we have about 40,000, and our goal is ideally to record all of those and make them accessible in 3D. So how do we do this then? For sites and landscapes, we use a combination of aerial LiDAR data, terrestrial laser scanning, photogrammetry, photography, and GNSS referencing. So this is actually one of the most exciting Antonine Wall sites. This is at Rough Castle, and these are the lilia, or pits, which would have contained a wooden spike covered over with grasses to impale the northern barbarians on if they tried to get into the fort. And this is the type of raw point cloud data we get from that. So this is the Roman fort. You can see the typical playing card shape here. And we can do nice things like look at the cross-section through that landscape. We also use structured light scanning for a lot of the artifacts that we have. This is an Artec scanner. We're using the Artec Leo now, which gives us a lot of flexibility. It's a new system, doesn't have any cables associated, has an online an inbuilt battery and everything, so nice and flexible. And photogrammetry as well is incredibly important to what we do, and we use a range of different setups depending on the particular object that we're looking at. And my colleague Adam Frost, who's in the audience somewhere, is going to be delivering workshops on what we do in terms of laser scanning and photogrammetry tomorrow. So those of you that have signed up will find out more about our techniques in that session tomorrow. And these are the types of artifacts that we deliver. So the Advanced LIMES project then, we had the opportunity to apply for Creative Europe funding, and this came at a time when we had been working on the Scottish 10 and working on the RAY project to have a certain amount of data under our belts already. And we wanted to work with our heritage partners, both in Scotland and on the German frontiers of the Roman Empire and Austrian side too, to create a mobile app effectively to house these 3D models that we have, to include augmented reality as well as traditional interpretations such as video and text, to create an engaging and interactive experience for visitors across the frontiers of the Roman Empire World Heritage Site. So the idea is that it will make the visitor experience more interactive. They can watch videos, handle virtual objects, and explore 3D reconstructed environments. We hope that it's going to improve understanding and access for users on site and enable users to virtually visit from anywhere in the world. And importantly for us, we want it to be a bridge between the sites and their artifacts, which, as I mentioned, are housed in many different locations across Scotland. And we want to have the ability to constantly update this. This is the Antonine Guard at the top here, who are a group of reenactors who are more than happy to dress up as Roman soldiers and look at our app for photos. We have a range of different sites across Scotland which are included in the app. Some of them I've mentioned already. Rough Castle, Bar Hill is a very important one for us as well, but very different and largely made of earthworks, so not a huge amount, as I've said, to see on site. But we're also involving our partners in Germany and some of the fort sites here and shrines, which have fantastic finds from them as well. So we've been developing the platform and capabilities with our developer who's based in Austria, Eric at EduFilm. And the platform now supports text, images, video, 360-degree visuals, 3D interactive reconstruction models and artifact models, and location-based augmented reality. And when we, part of the stipulation of the Creative Europe funding was to make this platform freely available at the end of the 3 years for partners and stakeholders so that they could then create their own content for the sites in their areas and to use this as a cohesive platform for across the frontiers of the Roman Empire. So the location-based augmented reality is an interesting part for us and something that was quite a technological challenge, given that a lot of these sites don't have particularly good Wi-Fi signal or particularly good broadband coverage at all. So our Austrian partner really has developed this. So it uses geolocation to, when you arrive at a particular site on the Antonine Wall, it will trigger a 3D model on your app, and it will pop up with a 3D model of the find that was located at that spot, and that's what you can see in the image there. So we've been rolling this out at a few sites, and it's almost ready now for widespread rollout. And you can also see virtual reconstructions of the fort as well, or the bathhouse, or whatever building it is at that location. So this has been quite a challenge technically, but something that we're almost there with. So as I mentioned, it's an open access content management system, and our partner at EduFilm has delivered this now for both the Antonine Wall and for the German Limes. So these are both now available to download through the app stores, and we'll be adding new content to them as we go forward. And we launched them just at the end of February in a digital symposium with our partners in Germany. So we would really appreciate if you downloaded. We're looking for feedback. This is still very much a work in progress. So give us your thoughts. So I wanted to go into a little bit about our data capture and processing workflow for how we get these models onto the app. So once we have the data captured, we generally follow this workflow here. And for photogrammetry, we primarily use reality capture for registration and for production of the high-resolution 3D model and textures. The optimization steps in a bit more detail, similar to what Felix showed earlier with his optimization, I think. We use instant meshes, which is one of the tools we use for optimization and retopology. We also do use 3D Studio Max and Blender, but instant meshes allows us to have an automated process, and it works well for artifacts such as these that we have for the Antonine Wall and the German Limes. So we automatically set the target number of polygons, and the software then reduces the model to that number. And for the app, we aim for about 2,500 to 5,000 polygons. The next step is unwrapping the UVW of the low-res model and baking the high-resolution texture and detail to the low-resolution model. This is the unwrapped UVW in 3D Studio Max. And this is the high-res diffuse map being rendered. And there it is applied to the low-resolution model. And then to bring us on to the final optimized 3D model, here we're showing it in Sketchfab, but this is the same process we go through for upload to the app. So we apply a high-resolution normal map, which is baked at the same time as a diffuse map. So we project the high-resolution detail onto the final optimized low-resolution model to give us this optimization. So we've been visualizing a series of these artifacts. We have over 100 of them now for the Antonine Wall and for the Roman Limes. Some of them have been quite challenging in terms of their reflectivity, but we've been trying to develop some workflows to combat that issue. And then using photogrammetry to capture, we've then also been taking that forward to virtually reconstruct how these columns in this case would have been superimposed, well, would have been a part of this building at one of the Roman sites along the Antonine Wall. And likewise, we've been doing this for other artifacts to help in their interpretation. So these are fragments of a leather shoe, which was found at Bar Hill Roman Fort site. So we carried out photogrammetry of each of the individual components, each of the fragments of the shoe. And then what we were able to do was to effectively digitally reconstruct this to show how it would have looked originally. In the museum where it's on display, it is literally in these various fragments, so it's very difficult to get a sense of how it would have looked when it was worn by a Roman all those years ago. And we've been doing the same type of thing for forts as well. So the 3D modeling that we've been doing on the larger landscape scale for virtual reconstruction is based on 3D data from aerial LiDAR in this case, and from site-based photography, photogrammetry, excavation reports, and expert archaeological advice and review. And we've spent many a day sitting with the archaeologists who dug a lot of these sites, and trying to get them to reach a consensus on what the gates might have looked like has proven to be quite a challenge. But we've got there, hopefully. So an important thing with what we do, we invest a lot of funding in creating this 3D content. So being able to reuse that in several different ways along our digital journey is really important to us to maximise the dissemination opportunities and to deliver value for money. So the content that we've created for the app, we're also then reusing in each of these ways here. So for interaction and engagement, we're looking at Sketchfab and virtual reality. For learning, we've developed a game, which I'll show you in a minute. We're using it for research purposes and then for visitor experience. So Sketchfab is, as you all know, many of you are using a really engaging platform, and we currently have 74 models on our Historic Environment Scotland website specifically for the Antonine Wall. We have about 250 overall, and that's getting us lots of views in the amount of time that we've had these on here. So a really great way of us being able to bring these artifacts virtually to our audiences. And virtual reality. We're lucky, where we're based, we actually have a visitor centre, small visitor centre, so we regularly have visitors in and we can transport them to the Antonine Wall or other heritage sites around the world. So using the photogrammetric models we captured for several of the artefacts on the Antonine Wall, we also then reused them from the app to create an interactive learning resource, an interactive game effectively. So this is the storyboard that you can see here, and we worked with a learning consultant to be able to tell the life effectively of a girl who, this is her tombstone, and we know that she lived in the Vicus, the civilian settlement outside of one of the Roman forts in Scotland. So we wanted to aim this game at ages approximately 8 to 12 years old and incorporate these photogrammetric models into the 3D reconstructions of the fort itself, but following the day in the life of a young girl who would have lived here. So you have to carry out a series of challenges to help her get food effectively to survive for the day. And it uses the quernstones and the grinders and the mortaria that we have already documented using photogrammetry. So this is available, again, as a free app that you can download. It's called Go Roman. And this was one of our testing groups who gave us very brutal feedback, but we were really, we listened carefully, I think, so hopefully we've met all of their expectations with it. We've shared all of these photogrammetric models with our partners at Glasgow University who are leading on the Emotive project, which is storytelling for cultural heritage effectively. This is a Horizon 2020 funded project which looks at the emotional response to digital models from a storytelling perspective. All of this content is reused on our website. You can interact with all of the artifacts there. And then I just wanted to finish up with one nice example to show a different way that we're using this 3D data. So we captured this Roman distance slab using laser scanning, but this could just as easily have been done with photogrammetry. And this is a really important large distance slab, 2,000 years old, and the local community where this distance slab was found wanted to have it back. And this is in the National Museum of Scotland, so understandably, that wasn't going to be an option. So what we did was we laser scanned the museum, the original version, and we then worked with a quarry and a stone cutting company to CNC to write out the model in sandstone at 1:1 scale. So based on the 3D data. And while the original couldn't go back to the find spot, what then happened working with the council, and here's our Antonine Guard again, like I say, they come out at every opportunity, they're great. So we installed the replica at the find spot, and this was at the launch day a few years ago. So a really nice way to be able to use these 3D models to engage the community and to really reinstate a piece of their heritage, which they were very passionate about in their local area. So just to sum up then, some of the challenges and opportunities that these types of method bring to particular sites like this. The Antonine Wall, as I've mentioned, it really lacks extant archaeology, and the artifacts are located at lots of different locations. And the Frontiers of the Roman Empire is a transnational World Heritage Site. So how can we best use digital technologies to bring this heritage together? We've had some technical challenges in trying to create all of this content and to bring it together in a platform that's suitable to download, that's not going to be too big. But the opportunities are definitely outweigh the challenges we feel. So there are lots of opportunities in using the 3D data that we have from photogrammetry and from scanning to help us with heritage management of these sites, to provide virtual open access and tourism opportunities, to help us learn more about the heritage in a fun and interactive digital environment, for interpretation and engagement, and we hope to inspire some visits as well to the Antonine Wall. So that's all from me. Thank you.
Well, this is clearly a session about storytelling and sharing and engaging the public. So it's up to Victor to conclude this session with sharing.
Yes, thank you for making this conference possible and for sharing all your interesting and useful projects. I work at the Swedish National Heritage Board. We call it Riksantikvarieämbetet in Swedish. I will use my own computer for this presentation, so I need to connect it with the HMI cable. I've been working on putting together a best practice for publishing 3D models. And this practice is available online at Riksantikvarieämbetets website, and it's mainly aimed at museums and other cultural heritage institutions. This best practice gives a practical overview of the making and publishing of 3D models. It has been published both in Swedish and in English. You can reach both languages on the website, and it has been developed through practical experiments with museums in different parts of Sweden. I work at the Department of Digital Interpretation as an enterprise developer. And for me, in my work, it's very important that what I do is really practically useful for the museums. Being entirely web-based, this best practice, this guide, is also easy to change and to update. So why a best practice on publishing 3D models? Improved software and platforms for publishing has made 3D models easier and cheaper to make and publish than ever before. But due to the lack of knowledge and experience, museums often just don't take the full advantage of what this technology has to offer. So why should museums create and publish 3D models? It's a great way to make collections and cultural heritage sites accessible for people who cannot physically visit a museum or a site. It doesn't have to be due to physical conditions and disabilities. It might as well be geography. Perhaps you live in Australia, you have Scandinavian ancestry, you know where they come from, and you really want to check out some perhaps 19th century artifacts from this area of Sweden, and then you can do it in 3D. It's also useful inside museums and at cultural heritage sites, as complements to physical exhibitions. And because the models can be zoomed in and you can rotate them and show angles that are invisible to the naked eyes. So sometimes a 3D model gives a better view than the actual object. It's also a resource for various types of interactive applications. We have seen many of them during the last 2 days. Also for research, you don't have to handle the original objects, and you can also take objects in their digital forms from different museums, from different parts of the world, and put them side by side and compare them. Printed 3D models can also provide tactile support in guiding exhibitions. So I see 3D models not as an end and a method unto themselves, but rather as a complement to and a way of enriching other media and methods for cultural heritage interpretations. This is what I do when I don't work at the National Heritage Board. A bit of wood carving on top of my laptop. It's a great way of ruining the keyboard when the wood chips sneak in. This image shows how I used 3D technology to make a very analog wooden copy of a medieval rune calendar from Lödöse in western Sweden. I started by visiting the museum, making a photogrammetry model of it, uploading it to Sketchfab, and then I could use it as an aid to place the runes in the right positions and to make the right shape of the rune calendar. So that would be impossible to do at a museum, and you couldn't just handle an original medieval object in that way. So that's a way of using it, not only digitally, but also for physical interpretations. 3D models are not just for, I think the mouse ran away. I think it's looking, it's looking for its friend somewhere here on the floor. So this technology is not just for digital professional use, you can use it for many other applications as well. Doing reenactment, we saw some nice Romans here, is a worldwide subculture. So then 3D models are really useful if you want to make reconstructions of costumes, weapons, jewelry, and other stuff. It's a resource for practical, creative, artistic work, for design, experimental archaeology. If I, for example, want to make myself a nice Viking costume, I need a buckle for my belt. So I can go to Sketchfab, search for Viking belt buckles, download a nice specimen, print it in plastic, and then use it for casting in bronze or other metal, either through making a sand mold using the plastic as a template, or I can print it in wax and use the lost mold technique, or I can make a mold out of rubber, out of silicone rubber or plaster of Paris, and then use that one to cast wax originals to use in lost wax casting. So how do you make a 3D model from the beginning? This best practice does not focus on the technical aspects of 3D modeling, but I want to give a brief overview because I want the users to understand what the technology can do and cannot do. Museums are often on a tight budget, both when it comes to time and to funds, so they really have to choose the right method for the right application. There are mainly two methods: photogrammetry, laser scanning, could be used separately or in combination. Laser scanning is best suited for work which requires a high degree of precision across large surfaces, like big buildings or rock carvings spread out on large surfaces. Photogrammetry is better for creating photorealistic models like artifacts and such things. where precision across large surfaces is not of any practical importance. But maybe the most important thing is there a story to go with the object? How do you tell the story? Is there a human context to put it into? I have also listed the pros and cons of different techniques, like this on laser scanning. You get a high precision, it's an automated process. The margins of error are down to the capacity of the technical equipment, so you reduce the risk of user errors. It's quicker than photogrammetry, but the equipment is really expensive and completely out of reach for most, at least Swedish museums. And it's also unable to accurately reproduce texture surfaces. Pros and cons of photogrammetry: it's really cheap equipment, you can start easily. Upgrades are mainly in the form of software, so you don't have to buy expensive hardware every now and then. And you get really photorealistic and visually appealing models. The big drawback to photogrammetry is that it's really time consuming, and it's also largely a manual process, so it requires some skills and experience. So the computer is trying to change the slide and will show a picture of really basic photogrammetry and what it looks like. So that's what it looks like when you start out on a budget. You have an old Nikon D90, a tripod, and a turntable. I bought it at IKEA. It's a serving tray, you can rotate it. It's called snudda. I don't know if it's a funny or rude word in any other language, but in Swedish it means touch lightly, to snudda something. And then I have painted it white and put 15 degrees markers all around it, so you just turn it around by hand. A light box, a soft box, and 2 lamps, and then you are going. This is from a workshop a month ago at Gamla Uppsala, Old Uppsala, north of Stockholm, on a hands-on workshop for museums. And this is how you make the model itself. That's the rune calendar. It was straight in the 13th century, but it broke during the excavation. You can straighten it out digitally, but I think it's also a point in having it in its original broken shape. This is reality capture, one of the most common softwares to use for 3D models. Some also use Agisoft Photoscan. It has changed its name to Metashape, but it works basically in the same way. Or if you hire someone to do it, because if you don't have an agreement to start with, you end up with lots of material which you maybe can't use yourself. When you make a photogrammetry model, you end up with literally hundreds of high-resolution photos. And if you don't have an agreement, maybe the photographer decides that he wants to keep all the photos himself, and he can claim he's got copyright of them and no one else can use them, and it really sucks when it happens. And it has happened before, so make proper agreements. And if you haven't done it before, do also expect a fair amount of time-consuming trial and error when you are starting out with photogrammetry. All objects are unique, some are more or less good for this technique, so there will be some experimentation. I have also listed some pros and cons for doing it yourself or hiring someone to do it. If you do it yourself, you have full control of the process. It's done on site, but you can also have a low production capacity, and the training staff also requires time and resources. But you will accumulate knowledge and experience for future projects. If you hire someone to do it, you will have a high-quality production and an efficient workflow, less risk, more efficient use of time and funds, but you have less control of the process. You won't accumulate any own experience from it, and objects are also handled by other than staff. And then I will move on to the next step. When you have your models, you will have to publish them somewhere. If you publish them online, anyone with a computer, even my dog, can search them and find them. Make your 3D models searchable, findable, and usable. Publish them online with a descriptive text, metadata, tags, other information, relevant links to more information on other sites like Wikipedia or your own website. Then you have to think about, should others be able to freely download, print, process, and reuse the models, including for commercial purposes? For example, in VR and AR applications. If not, why not? There seems to be, at least in Sweden, some kind of phobia regarding to make 3D models freely downloadable. I don't really know why, because you won't damage the original objects, whatever you do with the 3D models. Examples of external platforms, Sketchfab. We have seen some examples of it today. You can also use other platforms. This, I want to show you what it really looks like when you publish it on Sketchfab. There is an object, and I don't know what has happened with this link. It just won't work for me. It's a Neolithic ceremonial axe from the Swedish Museum of National Antiquity. I can see it on screen here on Sketchfab, but for some reason it just won't move on to this screen. This is what it looks like. But this is not the original Neolithic axe, it's a 3D model. So I downloaded it from Sketchfab and I sent it to a company specializing in 3D printing. This is some kind of composite, it's plaster and some kind of resin, epoxy in it. It's a bit brittle, so you shouldn't drop it onto the floor, but it gives a really nice representation of what this axe originally looks like. Oh, there it is. That's the original one, complete with annotations, so you can click and read about the details of it. There is a hole. Oh, all right. So there it is on Sketchfab, and this is the 3D model of it. So this gives you a really good tactile representation of the axe itself. There's a hole in it here, it's for a staff. There are rock carvings in Sweden where you can see it held by human figures on top of a staff. So you can also use this for reconstructions. I will pass it around so you can feel it. I also made some smaller copies, and a big one. This is in a rather soft plastic. We call it ninja plastic because you can drop it and handle it. It's great if you work with kids. Put a staff on it and the kids can play with it. They can bash each other around the head with it or smack it onto the floor, and neither the heads nor the floor will break or the model. And this ninja plastic model, I sent it to a stonemason, and he made a copy by hand. So this is no CNC object, this is real handicraft. So you can really feel the weight of the original axe head. I will just click through here onto the last slides. These are the ones. This is what it looked like when he started cutting it. So it's really traditionally made. I contacted the museum stores. I made some suggestions for jewelry. So I have printed these in plastic. They are rather small, like for earrings and necklaces. You can also print in metal through laser sintering, so you can get a really good view of what it looks like when you then will cast it in silver and other metals. I did this work around Christmas. And when I applied with my modal mouse, I realized that I could use it as a candlestick. So use your 3D models creatively. Thank you.
Well, if I could invite our speakers to have a seat, and we'll have a Q&A session, please. Do we have questions off the bat? Well, I have one for the Smithsonian team. An issue that I constantly face is coordinate systems. You have an object, and let's say you do photogrammetry, and you're unable to see the hidden portions, and then later some technology comes along that can see that, and now you have two kinds of data sets for the same object. So how do you deal with that? Is there a master coordinate system for an object, and do you reference to that? And then the second related question is, do you have a temporal coordinate associated with your object, so that if an object changes because it falls and it cracks and now you scan it again, that you relate these two moments in time to the same object?
Is this on? Great. So to address that, first is the kind of that item idea that we talked about. That is for your temporal component. If I scanned this table today, and in a year I scanned it again, that's going to have two different projects it's associated with, and those might be two different items. So I could define that in different ways if it changed. If it didn't change, I would just have the dates of the scan. That would tell me the difference. In terms of the coordinate system, each model, when we bring it into the repository, when we say it is a master model and we assign it a DOI, a unique identifier, that coordinate system is the coordinate system for that model. Every annotation we make, all the Tor information we include around it, those transforms are kept track of. So no matter how we're presenting the model online or in whatever platform, we can always track back to that original coordinate system and those annotations and content we've added. In terms of taking another model and adding to it, that would be a new derivative model, right? If I took a model that I had assigned a DOI to, I cited it, I wrote a paper on it, 5 years down the line, I CT scan, I create more data, I would actually, the source data for that new model would be this original master model, the CT data, and I'd have a new model that I've created with its own coordinate system that I could link back to the other one, but it's going to be its own citable model.
But if, for example, you had a macro an XRF scan of a point on an object, do you say this scan happened at this location on this photo that I can see of the surface of the object, or do you attach an XYZ coordinate to the scan? Or how do I know that this data from the scan is attached to this point on this object?
That depends on the scanning method. I would say for a lot of proprietary methods that we're not keeping track of that because it's in proprietary software, it's locked down, we can't get to it. For photogrammetry, we're saving that photogrammetry project and all of the the bundle package, all that auxiliary information, so we can map back to where that photo was compared to the model. Mm-hmm. But it really depends on the technology you're using.
Okay, thank you. Yeah, I have one question for Lynn. 25 years is a staggeringly long time in terms of the developmental arc of technology. So how do you deal with the fact that you have to put your chips on some technology, Sketchfab, for example? If we had put all of our models on Google+, well, they're gone now, right? Or let's set up on Alta Vista search engine or whatever. In 25 years, the technology that we'll have now is totally different. So do you build into your process that you continually reevaluate technologies and have a way, another similar idea is with the Golden Gate Bridge. You don't paint the bridge once. You continually paint one side and then you paint the other and you paint the other. And so as resolution gets higher and higher, do you continue to scan the same objects, or how do you deal with this problem?
Yeah, it's a challenge, definitely. We've been doing this since 2007, and we do have a long way still to go. What we've always done with particularly our sites and our castles and things is we aim to scan at the highest resolution that the technology will allow. So that effectively future-proofs us in terms of being able to reuse the models as best as we can. We use the raw data and the process data as our fundamental basis for going forward. Sketchfab and Google+, these are very much temporal platforms and not something that we can rely on for the future, effectively. Of course, we very much hope Sketchfab is going to be around for the future, many, many years. But we do use, the data itself is what we come back to, and we will scan again. We've just scanned, very similar to the Golden Gate Bridge. We have the Forth Bridge in Scotland, which is now our 6th World Heritage Site, and we've just scanned that. But we do go back, and particularly for condition monitoring, we will scan things that are susceptible to coastal erosion, for example, on a different annual basis and monitor change. So it's very important to be able to have that as a fundamental basis rather than relying on a different bespoke platform, I think.
Thank you. I think I saw some questions out here. Yes, please. In the back.
Thank you so much for really interesting presentations. This is to the Smithsonian. I was wondering who your target audience is in terms of annotations and the storytelling that you're doing and the information that you're providing. And then related to that, as an encyclopedic institution, it's obvious you're not going to be able to 3D scan all of your collection. So how do you prioritize which objects are going to get 3D scanned and which are not?
Thank you. In terms of the target audience, I think that really depends. We are building the storytelling platform, and then we leave the target audience up to the particular museum or the unit within the museum. So we've had curators that are clearly targeting a very academic audience use the tool. At the same time, we have educators using the tool for K-12. So that's sort of something that's offloaded to the authors of the stories. So we're building the platform. We are focusing on educators, and we have done a series of interviews based on the past 3D viewers we worked on with Autodesk, and we just asked them to kind of tear it apart, tell us what works, what doesn't. And at this point, we are at the stage where we've matched the functionality of those old Autodesk viewers, and now going forward, we're looking at implementing some of these requests that the educators are making. In terms of how we prioritize collections, I work for the Digitization Program Office, so I run one program, the 3D program, but then there's also a metrics and analysis program in our office, and they run something called a unit digitization plan. So every 3 years, the 19 museums nominate their priorities for digitization.
Okay.
Sort of in keeping with that, you may have just kind of answered my question, but I just wondered directionally if the ideas for your storytelling, 3D storytelling, begin in your group and extend then out to the curatorial groups, or is it the other way, or is it sometimes both ways?
I think it's a back and forth. In the beginning, it was a very new thing, so we would definitely make suggestions. So often it's a conversation, and we will have essentially like a brainstorming session because there are some things that are just technically not possible, so we kind of have to balance that. So we'll usually have a meeting with all the stakeholders involved where we can represent like the limits and possibilities from the technical perspective with the desire of like the storyteller and end up storyboarding something.
Oh, sorry.
So I first thank you guys, Smithsonian guys, and particularly the viewer. I can't wait to get my hands on it. But the question I have is about, it's great that it's going to be open source, but how easy is it going to be for somebody that's creating models to take the viewer, put it on their website, incorporate their models and the storyboarding and all that?
Yes, so I would say we probably have two phases. We're now in the kind of heavy development phase. So we're really first addressing other developers who help us shape the functionality, but eventually the idea is really that this is a fairly easy to use package that also supports like all the standard model formats. Right now it's really tailored because Smithsonian is basically, we are our first client for our own tool, but we really want to open this up, improve documentation, and based on the feedback we get, also we hope that we can really improve it to the point where it's really easy to use. Because I see using commercial tools has pros and cons. Sketchfab has a super great platform. It's the highest quality that you can get at the moment, but you pay the price of using a commercial platform that you don't know exactly what happens to the data, how it's managed, and if it's still there 10 years from now, right? So our approach is really that we provide something that you can host on your own. It's easy to host, so for example, you don't need any specific server infrastructure. If you can host a WordPress website, you'll also be able to host our viewer. And we think this has also certain advantages.
I have a question for Victor. I think you did a very nice job of showing all the possibilities and the fact that there are always trade-offs in terms of which capture technology you use, so, and the costs and so on. So given that there are so many possible uses for these models, there's scientific, there's preservation and documentation, there's entertainment, there's education. How do you assess whether or not the choice that you made is the right choice? You know, does the number of views on Sketchfab tell you something that makes you feel like you've made the right choice, or how do you tell if you did the right thing?
So if people are visiting your models on Sketchfab, and if they download it, then you have done the right thing. So when you publish something, I think you have to think about for whom and why are you publishing these models? Is there any interest around them? Do they fit into any ongoing project at a museum? So I think if you start from scratch with doing 3D modeling, perhaps you should choose just a few objects and then evaluate and make other choices or continue with the same choices.
Yeah, but to expand on the question, I don't have an opinion, but for example, let's suppose that you made a 10 million polygon suitable for scientific use model that gets downloaded 50 times because it's enormous, or one that has 2,000 polygons that gets loaded 10,000 times. Which one is better? How do you tell?
They are both good. They are better in their own categories. I think that there are different models for different purposes.
Okay. Well, do we have one more? Yeah, one last question then.
Yeah, it's still remarkable. One observation is that it's really critical when you're doing 3D production to archive your data, your original images, your metadata, any 3D work projects, separately from any presentation device, because I think your likelihood of long-term preservation of data stored separately from Sketchfab or some one-off web viewer, and there's a certain point where something there's going to break. Usually the developers have moved on, and if your data is locked up in the presentation method, you're just done, right? So always keep your data separate from your media. The second observation is that if you know where to stand and point the camera, you can get higher precision, or at least equal precision to the best laser scanners using photogrammetry. And the learning curve is not that steep in terms of learning the capture methodology. Most people can do it in about a week and then add on with experience. So I think there's a misconception out there that lasers are more precise or accurate, in quotes, than photogrammetry, and that is simply empirically not true.
Well, yeah, please join me in thanking our speakers again.